Can you tell me real number? Because it can be defined for each. It can be defined for each real number. Okay. Okay. So now case first. If x is a discrete random variable, if x is a discrete random variable, then what will be the formula for mxt? Mxt will be equal to, because it is the formula is e to the power tx. Now my random variable is discrete. How? What is the definition of expectation? It will be goes to j goes to 1 to infinity e to the power tx I t tj px xj, because random variable is discrete. The definition of expectation will be defined like this way. Now case second, if x is a continuous random variable, if x is a continuous random variable, then what will be it? Okay, what will be the definition? Mxt will be what? Mxt will be equal to, because random variable is continuous, what will be minus infinity to infinity e to the power tx fx dx. Okay. Note to mxt may not exist, may not exist for all t, may not exist for all t. It may possible that it does not exist for, okay, for all t. So here mxt can be function r to r, possibly maximum domain for mx can be r. Okay, maximum domain, because this is integral and series do not possible to convert some values of t. Okay, or integral do not convert to some value of t possibly. Okay, so mxt may not exist for all t as the infinite series, because summation j goes to summation j goes to 1 to infinity is an infinite series, or this is integral minus infinity to infinity. This is improper integral may not converge to a finite value. Okay, may not converge to finite value. It may possible that mxt is not defined for all t. Maybe for some t it is not defined, for some t it is defined, or maybe it is defined for all t. Okay. Note third is What is value of mx0? Okay, what is value of mx0? So it will be e to the power p0. Sorry, e to the power 0 x. So what will be? E to the power 0 will be, it means e1. The expectation of a constant is same as constant. So it will be 1. Okay. So this was the definition of MGF, moment generating function of a random variable.